Thanks for coming to my presentations. I'd like to start my presentation now. My presentation title is Using RT Preempt Patch with LTSI Kernel. My name is Yoshitake Kobayashi. I'm working for Toshiba Corporation for 6 years now. And I work on embedded operating systems, not only Linux, but also real-time OS. Such as microRTron or VxWorks, something like that. But most of my work related on Linux. And some of my work related on open source software license issues, such as GPL or the other license issues. So, this talk will focus on how to use RT patch with LTSI kernels. Currently, LTSI kernel doesn't have RT patch included in. So, in this talk, I'd like to show how much the RT patch to LTSI kernels. But I also uploaded my source code for LTSI kernel with RT patch on GitHub. If you're interested in, also, if you'd like to test for that, please copy it from here. And this presentation, expected experience level is beginner, because this is not difficult, not deeply into the RT patch. If you'd like to know about the RT patch, there are really good references for real-time preemption patch here. Frank's real-time failure to describe what real-time system is, and Steven's presentation also describes deep inside the real-time patch. If you would like to know something like that, you can refer such kind of presentation materials. So, this is my presentation overview. At first, I would like to explain the recipes, what kind of ingredients needs to cook LTSI-RT kernel. Then I describe 4 steps to make LTSI-RT kernels. First step is a very basic step. To use LTSI kernel patch. And then I should explain merge RT patch with LTSI kernels. After that, usually we get conflicts while merging the RT patch with LTSI kernels. So I can show how to resolve the conflicts in these presentations. After that, I can show some demos, what kind of demos we usually doing, or what kind of tests for. And after that, I concluded my presentations. So first, the recipes. Oh, sorry. Yeah. Of course, this is LTSI-RT kernel, and LTSI kernels based on stable kernels. So we need a stable kernel at first, then LTSI kernel patch trees. Both trees available on the web, and also RT preemption patch. Of course, we need it. This tree, source tree, is needed to make the LTSI kernel, LTSI-RT kernels. So, and to create the LTSI-RT kernels, we usually use such kind of commands. Not many, but if you know about much better way, please let me know here. So, there are 2 scenarios to create LTSI-RT kernels. First scenario is at first make LTSI kernel first, then merge with RT patch. The second scenario is at first create RT kernel first, then merge LTSI kernel patch. To compare two candidates, I can say RT kernel patch is usually make many modifications to core kernel part. So that means if I try to merge LTSI kernel patch with RT kernel, it will be difficult, much difficult than this one. So as a reason, I can use these scenarios. At first, LTSI kernel, then merge with RT patch. Yeah. To start, explain how to merge LTSI kernel and RT patch, I would like to explain the release schedule for LTSI kernels. LTSI kernels not follow all LTS release. LTSI kernel only release for some point of the, for example, 3.0 releases. So, for example, 3.0 LTSI kernel available for 3.0.38 to 3.0.101. And 3 versions are available. And also 3.4 is under development. Now still support phase, and there are 3 releases are available now. At first, we create LTSI-RT for version 3.0.31 because this is very beginning. So it is better to explain how to create LTSI kernel. After that, we usually follow the LTSI-RT kernels. But someone wants to have recent fixes between 2 versions. So in that case, we can also follow the LTSI with LTS versions. So in my Git tree, I created, I think, almost all release points. So if you would like to have the latest one, maybe you can have it. So this is very first step to use LTSI patch. To create LTSI kernel, we need a stable kernel and LTSI kernel patch. And this slide describes how to create LTSI kernel. At first, need to prepare a stable kernel source tree, like with user git clone, and check out the target versions. This slide describes how to create a version 3.4 LTSI-RT kernels. So I use 3.4.46 at the beginning. Then clone the LTSI patch tree get from the Linux Foundation site and checking out the related version from here. And then LTSI patch we are able to apply. There are some ways to apply the patches. If you want to use some scripts also included in the LTSI kernel git tree, but you can do it manually using git create import or kill commands. And after that, we need to merge RT patch into the LTSI kernels. So at that time, at first, at remote git tree as for the reference, and then try to find the relative RT patch here. So in that case, I can show you git log Actually, this is version 3.4.46 LTSI-RT. When you check the makefile, this is version 3.4.46 LTSI. So, and then git tag grep 3.4.46. Oh, takes a bit long. Okay, I find this RT versions. So git just merge it. Merge. Try to merge. Yeah. My computer is a bit slow. It takes a bit long. So now it's working. Okay. Yeah. And at that time, there are two conflicts here. Yeah, only two conflicts are there. So of course, this is two conflicts. So in that case, when we get the conflicts, we have to think about the modification policies. And I recommended this one. All bug fixes need to be merged, but API changes might be resolved. So because some LTSI kernel parts modify the core kernel part, in that case, it's difficult to resolve. So at first, you can try to fix, but if you think it takes a bit long or you don't need some kind of features included in the LTSI kernel, you can simply ignore a patch. So in that case, what kind of conflict? We have to think, make sure what kind of conflicts are there. Yeah. And this conflict is very simple one, because LTS and RT patch added include file. But LTSI kernel also added include file, but different included file added in the LTSI and RT patch. So in that case, just use both. Yeah, and then I can show you. Yeah. In 3.4, it's easy to fix, but we need to consider about the when you are checking the conflicts, you need to consider it's related on the RT patch or LTSI kernels. So to check the LTSI conflict, you can use a grep command to check that. Also, you can also use git merge tool to check that. But I usually do it by the command. It might be easy for me. Yeah. But to make the version 3.0, it is very old one. But it was a bit difficult than version 3.4 because the version 3.0 included many modifications to core panel part. So, okay. And also, LTSI kernel version 3.0 released on the version 3.0.38 first, but RT patch is not available for 3.0.38. In that case, at first, we create a LTSI kernel first, then merge it to the version 3.0.39, because this version have a relative RT patch here. So In that case, we can use like that. Okay. LTS Linux kernel stable 3.0 git log. Okay. Yeah. This is LTSI version 3.0.39. When I merging the git cat, sorry, the step 2. Okay. Version when I merged version 3.0.59, there are many conflicts occurs here. So we need to check the conflicts, and this slide just included all conflicts when I'm merging the LTSI kernel with RT patch. And as you can show, there are some RT patch related changes maybe made in. For example, RT mutex or PDS is a very basic part of the RT patch set. And in that case, we can choose simply ignore this this related patch here. The reason why is, for example, okay, dot rep dot LTSI kernel 3.0. Yeah, this patch may have modification for plist, and when I check this patch, okay. Yeah. This patch described this was legacy code brought over from the RT tree and is no longer necessary. So that is that patch caused the conflict. So, but unfortunately, there are many patches also related depends on this patch in the LTSI-RT tree, LTSI kernel tree. So, but in that case, I can just and I edited the series file for 3.0. Yeah, there are lots of patches, but plist patch related on the runtime power management feature for LTSI kernel. But this patch caused a serious problem to merge the RT patch. So, and I consider, okay, I don't need runtime power management, and I just ignore the patch series. So I decided all patches just commented out from the source code. Then git reset hard hit and git branch. Okay. Then merge it the LTSI tree and git checkout. And yeah, this I have already created omitted version 3.0.39 LTSI. This tree not included power management stuffs and also the related stuffs on it. And after that, I try git merge. Yeah, that's much better. auto merging, and yeah, it's simply successed. So this is how I was created version 3.0 LTSI-RT. So that means when you look at the GitHub, you don't have, you are difficult to have a runtime power management with LTSI-RT with LTSI-RT version 3.0. So if you would like to porting, please try it. And I'm pretty sure if you send me a feedbacks. So. Yeah. After merging the LTSI kernel and RT patch, it covers the gray part. If you are difficult to see the colors, yeah. The cover area is LTSI architecture independent part and RT preemption part and it's Linux kernel. But LTSI architecture dependent part is may not covered, and we need, if you use LTSI architecture dependent part with this kernel, may cause some problems. Sometimes the latency issues, and sometimes deadlocks, and sometimes I don't know because I haven't tested all of things stuffs. So that means, yeah, we need to test. So at first, when we created a LTSI-RT kernel, at first we tried to do a compilation test with our config or mod config, but this is not usually used with RT patch. So we use usually use a customized configuration with RT patch, and this configuration must be included config Preempt-RT foo and high resolution timer, and of the power management stuffs and debugging stuffs, because debugging stuffs causing latency issues. So at first we created RT kernel with these basic options. And yeah, if you would like to know about these kind of things, yeah, there are good tutorials available here. And after that, we usually do the many tests. This is just an example for the tests which we are doing. And at first, LTP for API testing, and also compare the original RT kernel and the LTSI-RT kernels. If the test result is different, may have some regression issues. And after that, we also test the performance test. Performance tests include the latency test with a cyclic test, and also a netpath for networking performance, and I/O tests. And this is very basic. And also a storage test using a CPU storage test and data reliability test. And data reliability test means if the some power fail causing while accessing the data, it is okay or not. Yeah, we also evaluating something like that, and also power on and off test. And currently, we also are focusing to use hardware isolation, hardware resource isolation test to make real-time and general purpose world into one board. So, I can show you the demo. Yeah, this is an example for isolation test or isolation demo. And at that time, we use a Pandaboard. Pandaboard have a 2-core processor, and we use one for general purpose is web server, and the other one for controlling this robot. And this robot sending the sensor values to the Pandaboard through the CAN device and the RS serial device. And the RT control process have to calculate the motor torque, within the deadline. The deadline period is about 3 milliseconds, but in the 8 millisecond period. So, and when the web client accessing to the web server, it is not deterministic. So, if this environment not isolated into the two parts, it causes latency problems. So, okay, this is not isolated one. Yeah, and it's a bit difficult to see the maybe this graph. This graph is a CPU workload, and currently this part. Oh, sorry. This part is red. That means not web client access occurs. But when web client accesses to the Pandaboard, both CPU workloads going to the about 100%. So as a result, it's difficult to use that. Let's start. But if demo materials, let's read. Okay. If the system is correctly isolated, even, oh sorry, maybe wait a bit more, even web client accessing very high, and only one CPU core going to the 100%, and the other core is very stable level. So that's able to keep the deadlines. So sometimes we also doing some isolation tests and this is not the test. This is just demo, but to make this kind of work. Yeah, and actually this original idea comes from some website, and we created the same one based on that. But an original idea based on the one virtual machine use two kernels, one for real-time OS kernel, the other one for Linux kernel, with, for example, Android. But in my demo, we use only one Linux kernel, which is isolated with real-time world and general purpose world. Yeah. So this is a difference. So, and when system has a latency issues, in this presentation, I'm sorry for that. I don't explain the very details for that. But we need to find out the latency bottlenecks using the profilers and also FTRSs. Yeah. To find the no. I think I have some example which I presented in maybe 2 years ago in ELC using FTRS to find the latency bottlenecks. So, yeah, and you can find to use bottlenecks using this kind of tools, and then you need to fix it because if you want to use LTSI-RT kernel with new board or LTSI kernel supported board, I'm sure you need to find some issues because I'm not using that kind of part, but someone wants to using that kind of part. That means, yeah, I don't test it yet, so that's why. So. This is my presentation conclusion. This presentation shows how to create the LTSI kernel with basic knowledge for that. And its source code is available at the website. But currently, we only have 2 versions because now LTSI version 3.10 is available, but we are still testing for LTSI-RT kernel. So LTSI-RT, LTSI 3.10 RT kernel will be available soon on same one. And if you find that, I'm pleased if you send me feedbacks. Thank you for that. Any questions? No? Okay, thank you very much.